Alright, so number one is negative 5 minus 9. So I'm going to change the minus 9 to minus 7 for class. So there's a couple ways of doing it. So let's say it's a 5. So where's 5 on this chart? Oh my goodness, I can't see the cursor. I don't know how to make it. Hold on, before I begin I need to make the screen brighter. Okay, so I can see. Alright, so 5 is about here, alright? And it's asking us to subtract how many? I guess for this question, let me make it all even. Let's say it's 4 minus 10. Alright, there we go, that's better. So we'll start at, this is number one, something similar. We'll start at 10 and subtract 4. Excuse me, we're starting off at 4. We're starting at 4 and we're subtracting 10. There we go. So that's 2, 4, 6, 8, 10. The answer is negative 6. The answer is negative 6. Or you can do another way of doing this, is simply looking at 4 minus 10 and then subtracting them, taking the absolute value of it. Doesn't matter what it is, 4 minus 10 or 10 minus 4. Find the absolute value, which is 6. Then looking to see which number is larger. Well, 10 is larger. And then when we look at the 10, we look to see what sign it carries. Well, it carries a negative 10. So the answer is going to be negative 6. Alright, you can use that philosophy with anything, with any adding or subtracting, and it makes it a lot easier. For example, the next one is, next problem is, okay, we'll use a bigger one, is 5 plus, that's horrible, isn't it? Is 5 plus, we'll make it 4 plus 6. Alright, 4 plus 6. Same thing, we start at 4, then we add 6. 2, 4, 6. The answer is 10. Alright, does that make sense? I don't like that font. No, that's better. Alright, next is 5 minus 9. Alright, so let's have 4 minus 6. Alright, so all we're doing is, when we have two minuses like that, this becomes 4 plus 6, and 4 plus 6 is 10. Alright, that's all we're doing. We're doing 4 plus 6. That's what happens to that problem. Alright, number 4 is negative 5 minus 9. So I'll just make it negative 4 minus 6. Alright, so we start off at negative 4, which is over here, and we're subtracting 6 from it. So it's 2, 4, 6. So the answer is negative 10. Now an easy way of doing is seeing, since they both have negative signs, all we're doing is adding the numbers. So 4 plus 6 is 10. And since these are both negative, the answer is negative. Same thing like if it's 4 plus 6. 4 plus 6 is technically plus 4 plus 6. And we just add them, take the sign of both numbers, which is a positive. Alright? Alright, next problem is negative 5 minus 9. Alright, well, that shouldn't confuse you either. So we have negative 5 minus 9. Two ways of going about it. Let's look at the line chart. We have negative 5. So we'll just make it, well, I should make everything negative 4 minus 6. Alright. Same philosophy applies. Since these are both negatives, this becomes negative 4 plus 6. Negative 4 plus 6, we start at negative 4 and we add 6. 2, 4, 6. That becomes a positive 2. Or we'll just say negative 4 plus 6. And we'll look at it, take the absolute value of 4 minus 6, which is 2, and take the sign of the larger. Well, negative 4 is not large. 4 is not larger. 6 is larger, and 6 is a plus. So this is plus 2, just like how this is plus 2. Alrighty. And the rest of the problems are similar but in different variations, so we don't have to worry about that. Let's move on to number 7. So number is 5 times 9. Well, I should change the signs. Let's say it's 4 times 6. Well, 4 times 6 is 24. Next is 4 times negative 6, which is what? The combinations are negative times positive equals negative. Negative times negative equals positive, and positive times positive is positive. So knowing that, 4 times negative 6 is negative 24. Okay, negative 4 for number 9. Negative 4 times negative 6 will be positive 24 because negative times negative is positive. Same rules apply with division. Number 12. We have 6 times negative 3 times negative 18 times 4. So I'll change the numbers. I'll have 5 times negative 2 times negative 6 times 4. So what we'll do is we'll multiply these first like that. Alright? 5 times negative 2 is negative 10. Alright? Times negative 6 times 4 is negative 24. Alright, so then we have 10 times 24. Well, they're both negative, but the answer will be positive. We know that. 4 times 0 is 0. 4 times 1 is 4. And 2 times 0 is 0, so that's 4. And then 1 times 2 is 2, so the answer is positive 240. Okay, so that was easy. Alright, number 13. We have negative 56 plus 29 plus 186. So I have negative 4 plus 2 plus, 182. Alright, we use my dear Aunt Sally. My dear Aunt Sally, right? Which stands for multiplication first, division, then adding, and then subtraction. And there's other variations. So all we have to do is what first? Well, there's just adding and subtracting, so we do just by order. Actually, we go this way. So negative 4 plus 2 is negative 2. Negative 2 plus 182. Negative 2 plus 182. We just subtract, becomes positive 180. Alright, same philosophy applies to the rest of the problems. The next one is absolute value, so we'll just briefly go over it, which is negative 3 plus, I'll change the number around, negative 6 minus 3. Because there's absolute value, let's just do what's in the absolute value bar first. That is negative 6 minus 3 becomes a bigger number, that's negative 9. Let's take off the absolute value, we have negative 3 plus that, whatever's in the absolute value becomes positive, so that becomes a plus 9, okay? So negative 3 plus 9. We subtract and take the sign of the bigger, so negative 3 plus 9 is 6, and the larger number is 6. And the larger number is positive 9, so the answer is plus 6, or simply 6. Alright. 18. Well, with 18, and basically, let's say we have 9 times 9, and we have, let me say x to the 5th times x to the 4th. Alright, what we do with number 18 is, as long as the bottom numbers are the same, we can multiply the exponents. And when we have multiplication, and technically we're just adding these exponents, so it becomes x to the 9th power. For example, let's say we have 3 to the 2nd times 3 to the 5th. Because both numbers are 3, we just have to add these exponents. 2 plus 5 is 7, so it becomes 3 to the 7th power. Alright, and if it was division, let's say if this was division, we draw a division sign, then this becomes, and just subtract them, the opposite of adding. So this becomes x to the first, or just simply x. And let's say if this was division, it just becomes 3 to the second power. Technically, to the negative second power, but you understand what's happening. For number 20, it's a little bit confusing. You have we have, let's say, 2 to the 5th parentheses to the 3rd. Now this is different because when we have, let's say, 2 to the 5th times 2 to the 3rd, right? Since we're multiplying, we just add these exponents, right? And it becomes 2 to the 8th. But because we have this parentheses instead, all we do now is we technically multiply these exponents. So 5 times 3 becomes 15, so this is 2 to the 15th power. Same philosophy applies to the rest. If it was a negative, though, which actually brings an interesting scenario. Let's say we have a negative 3 times, let's say negative 3 to the second power times 3. Well, that becomes negative 3 to what? To 2 times 3 to the 15th power still. Does that make sense? So it doesn't matter whether it's a negative or positive, the number will, the sign will remain the same. Alright, 22 you can do on your own. Anything to the 0 power, let's say it's 8 to the 0 power, anything to the 0 power is 1. Okay. Number 24 is my dear Aunt Sally. Number 25, well, 25 is easy. Let's say we have 2 over 4 plus 1 over 4. Alright, we're adding fractions. Well, the denominators are the same, so we can simply add the numerators. 2 plus 1 is 3, so that becomes 3 over 4. Number 26, we have a square root, alright? So let's say we have 81, the square root of 81. That's horrible looking. We have the square root of 81. What we're trying to figure out is what two numbers, because the square root is technically 2, what two numbers, when multiplied together, that are identical will give you 81. Well, 9 times 9 does. So the square root of 81, right, equals 9. Okay. Then we come to multiplying and dividing fractions. Okay, multiplying and dividing fractions for numbers 27 and 28. Let's say we have 1/2 times 8 over 2. Well, let's say 8 over 10. Alright, before you can just simply multiply. 1 times 8 is 8 and 2 times 10 is 20, and then reduce, because 4 goes, we can divide each number by 4, 4 goes into 8 2 times, and 4 goes into 5. 4 goes into 20 5 times. Or you can skip all that and reduce in the very beginning, cross cancel. 2 goes into 2 once, 2 goes into 8 4 times. Then you can leave it at that, or you can even reduce it some more. 4 goes into 10, 4 goes into 10 no times, but 2 goes into 4 twice, and 2 goes into 10 5 times. And the answer is 2 over 5. Now, if it's division, we first have to change the problem to a multiplication problem. So you have to multiply the inverse. So this becomes 1/2 times, you have to switch these signs around, numbers around, times 10 over 8. Alright? Then now you'd work it out. Same thing, you can reduce. 2 goes into 10 5 times. Done. 5 can't go into 8. So the answer is 5 over 8. And then problem 29 is, well, let's do problem 28. That may get you a little stuck. So we have 5 over, let's say 4 minus 7 over 3. The problem is the denominators are not the same, so we have to find a common denominator. 3 can't go into 4, but 4 times 3 is 12, and they can have 12 as a common denominator. So let's use 12. 4 goes into 12 3 times, so 3 times 5 is 15, alright? Minus 12, right? Because we're multiplying each number by 4. 4 times 7 is 28. So now we have to subtract 15 minus 28. Alright, so I'll write it this way so we can visualize better. 15 minus 28 is 13. So the answer is 13 over 12. That is an improper fraction, but I'll leave it there. Okay. Number 30. Number 30, we went over square roots, alright? So this is 81, alright? And this becomes 9, right? Technically there's a 2, but many times we don't write it. But in some problems you'll see a 3 or a higher number in there. So if this was what two numbers gives us 81, they're identical. Let's say this is 27. Now we have to look for what 3 numbers, because there's a 3, will give you 27 that are multiplied together. Well, 3 times 3 times 3 gives you 27. 3 times 3 is 9. 9 times 3 is 27. So the answer is 3. Alright. Now if there was a negative there, there's no such thing. So after you do the answer, it should be a negative. It should be a 3i. 3 I standing for imaginary, because there can be no negative number in the square root box. Now if you have, the next problem is my dear Aunt Sally, so I'm not going to go over that. You need to use a little bit of common sense. But for 32, it may be a little bit hard for some of you. We have the square root of, I'll change it up. Oh, I'm trying to think of some numbers. 81 and 144. Alright. Same philosophy, looking for what two numbers give us 81. We know it's 9. And what two numbers timed together give us 144, the identical, which is 12. Well, look at that. And actually, we can actually reduce this, which is an interesting situation. 3 divided by 9 is 3, and 3 divided by 12 is 4. So the answer is 3 over 4. Right? The square root of 3 over 4 is 5 to the negative third power. This is really easy, so I'm going to use I'll use algebraic terms. So let's say we have x to the negative second power. To write it as a positive for number 33, all we're doing is putting 1 on top as a numerator and x, and change that negative exponent to a positive exponent to the second power. That's all you have to do. And so that applies to 33, 34, 35. So for number 36, it's already in positive, so I would like you to write it as a negative. So if we have, let's say we have let's say we have this problem, right? All we have to do to change it to the opposite again is take out that numerator. We're just left with x squared, and because it was on the bottom with it as the denominator, and we took off that numerator, that's 2 becomes a negative. That's all to it. Alright, so let me work with the number, for instance. Let's say I have 1, and I should use a number, 9 over, 9 to the third power. So I want to change that to a positive, I want to change that so that I have a negative exponent. So all it's going to be is 9. Sorry, and this will be 9 to the negative third power. So for 41, we have 3 to the negative second power times 3 to the negative 8th power. So it says solve in positive exponential form. Alright, so that's not hard. I'll write examples. Let's say we have 4 to the negative third times 4 4 to the negative ninth. Alright, and we want to make this into positives. Well, there's several ways of doing it. I think the easiest way right now is just to add them. So negative 3 plus negative 9 is going to be negative 4 to the negative 12th, right? Because all we're doing is adding them. Will be 4 to the negative 12th. And if I wanted to write that as a positive number, all I have to do is put a 1, make this into a fraction, put the 4 in it. 42, let's say we have 5 to the third divided by 5 to the sixth. Alright, after we divide them, we get 5 to the negative third. So because 3 minus 6 is comes out to be negative 3, so we have to change that to 5 over 3. Next is number 43, which is, let's say we have 3 to the third power divide by 3 to the negative 6th power. So when we do that, we get 3 to the negative third, and all we have to do is change it to a positive. So have a numerator as a 1, put down the line, put 3. Sorry, my computer is giving me problems. Next set of questions, 44 to 46 is just combining like terms. So I'm actually going to do one problem. I'm going to do 46 with you. So I have 2x squared plus 3x plus minus 8 plus 4x squared minus 5x plus 2. Alright, let's see what's like terms. So let's start with 2x squares. There's an x squared here, and there's an x squared here. So 2x plus 4x is 6x squared. Alright, so that's done. Alright, let's look at the 3 x's. We have an x here, and we have a negative 5x here. So 3 minus 5 is, you should be able to do this, but in your head right now is negative 2x. Alright, so that's done. So now we're just left with is negative 8 and I marked off the wrong thing. Well, anyway, plus 2. So we have negative 8 and plus 2. Well, that turns out to be negative 6. So there's your answer. 6x squared minus 2x minus 6. That is simplifying. And it's the same procedure for 44 and 45, which I'm not going to do with you. You should be able to do that on your own. Next is evaluate. So I'll do one problem with you. Let me do a tough one. Let me do 49. So 49, we have 5x squared plus 2x plus 7. And it's giving us x as 3. Alright, I'll put x as 3. Y is negative 4. And z is... there's no z in this problem, but z is 2. That's alright. So we have 5 times x became 2 in this place, to the second power, plus 2 times 3 for this case. There's no y, plus 7. Right? 3 squared is 9, plus 2 times 3 plus 7. Now we have to do my dear Aunt Sally, which is multiplication first, which is this. 5 times 9 is 45, plus the next multiplication, 2 times 3 is 6, plus 7. Now all we have to do is add them. 45 plus 6 plus 7. Right? So 40 plus 5 is 45. 45 plus 6 is 51. 51 plus 7 is 58. And that's all we had to do. Easy. Now numbers 50 to 61 could be a little challenging, but we can do it. Alright, the first problem is x minus 5 equals 126. Not hard at all. Let's go for it. So we have x minus 5 equals, I'll say 20. Alright. So we have to get x by itself. So we need to get rid of that negative 5. So what's the opposite of negative 5? Plus 5. So we'll add plus 5 to both sides. See, this 5 drops out, right? Now we're just left with x equals 20 plus 5, which is 25. That's the answer. Alright, that's an example for number 50. 51, we have, let's say, we have 2x equals, let's say, 48. All we're doing is dividing. We need to get x by itself. 2x is the same thing as saying 2 times x. And alright, there's a couple ways of doing this, but the easiest way is just to put a line here. Put a line here. Divide this by 2. Divide this by 2. And we get x equals 2 goes into 48 24 times. Or you can do a little bit more complicated way, which is saying, well, what's the opposite of if 2 times x? Then the opposite of 2 times x is 2 divided by x. And 2 divided by x is the same thing as multiplying each side by 1/2. And when you multiply each side by 1/2, this crosses out, and then we're left with x equal 2 goes into 48 24 times. Alright, those are two ways of encountering the problem. 52. Alright, because that's helpful, because 52 is an example of that. So we have, let's say, x over 4 equals 16. Alright, so we need to get x by itself. Well, what's the opposite? We have x over 4. The opposite of x over 4 is 4 over x, or simply 4 over 1. So we multiply each side by 4 over 1. This crosses out, then we're left with x equals 16 times 4. 16 times 4, well, we'll write it this way to help you understand. 6 times 4 is 24. 24, 64 is the answer, alright? So the answer is 64. Easy to it. Number 53 is an example basically of number 50. Won't go over that. Number 54, we'll go over number 54. So we have number 54. Let's say we have x over, let's say 6. X over 6 plus 3 equals 12. Alright. Same thing, we have to get rid of the 6, so we'll multiply each side by 6 over 1. And, well, even before we do that, let's first get rid of this 3. The 3 is in the way. So we'll subtract both sides from 3. There we go. We'll subtract both sides from 3. This crosses out. Now the new formula we're left with is x over 6 equals 12 minus 3 is what, class? 9. Now we have to divide both sides by or multiply both sides by 6 over 1, which is the opposite. Multiply this by 6 over 1, which is the opposite. Alright, this cross cancels. Now we're left with we're left with x equals 9 times 6, which is 54. And that's the answer. So that's how you would do number 54, 55, 56 is distribution property. Let's go over that. So for 55, let's say we have negative 2 times negative 2 times x to, let's say, the 4th power. To the 4th power equals 12. So same thing, we have to do distribution property. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 4, right? Equals 12. Well, we have to subtract 4 from both sides. So we have negative 2x equals, after we subtract 4 from both sides, equals 8. Then we have to divide each side by negative 2, because that's a 2, and you divide this by negative 2. And then once we finish dividing it, we get x equals negative 4, because negative 2 goes into 8 negative 4 times. Alright, I did that rather quickly, but if you sit down and think and look at the screen, pause it, you can understand and be able to do number 56 with no problem. Number 57 is just, well, 57 is just a longer version of 56. So let's check out number 58 and 59 together. So before we hit the next two questions, I thought we'll do 57 together, at least a similar example. That way you know how to go about it. So distribution property, 2x times 2, which is plus 2. You see that? Equals, same thing, 3 times x and 3 times negative 6 equals 3x times 3 times 6, negative 6 is negative 18, plus 3 times x, which is 3x, plus 3 times 5, which is plus 15. Alright, then you just have to simplify it. So 3x plus 3x is 6x. Negative 18 plus 15 is negative 3. And we have 2x plus 2 equals that. So we have to subtract 6x. Well, I'll subtract. Now it's difficult to figure out which side should go where. You can do whatever side, but I'm trying to think what is the easiest way. Easiest way is to subtract 6x from both sides, and we get negative 4x equals, and then we'll add, subtract 2 from both sides equals negative 5. Alright? And then you know what to do from there. After you do all your division, you're going to get positive x equals 5 over 4. Alright? So with numbers 58, we have 5x plus 9 absolute value equals 9. You can't do this problem until you have to write the problems two ways. You have to have 5x plus 9 equals 9, or 5x plus 9 equals negative 9, and then you solve the problem. Alright, so you will have two answers in the end. Then for the next one, you have we have 23 equals positive 5x minus 2. So what you want to do is get that 2 on that side. So you'll add 2 to both sides. So you get 25 equals absolute value of 5x. So, or you'll have 25 equals 5x, or negative 25 equals 5x. So you'll have two answers after you're done. That's how the absolute value works. We haven't really gone over too much, that's why I helped you out with it. So 60 and 61, I'm going to just do number 60 with you, and you can do 61 by yourselves. So we have x over 2 plus 4x over 3 equals 22 over 3. This looks tricky, but it really isn't. First thing is we have to have the whole thing needs to have a common denominator. So I'll choose 6. Alright. 2 goes into 6 3 times. 3 times x is 3x. Alright. Same thing. Next one, 6. 3 goes into 6 2 times. 2 times 4 is 8x. Equals 6. 2 times 22 is 44. Alright, all we have to do is now simplify it. 3x plus 8x is 11x over 6. Alright, equals 44 over 6. Now we have to get rid of that 6. So we need to multiply each side by 6 over 1. And multiply this side by 6 over 1. These 6's drop out. Then we're left with, I'll put that up here, 11x equals 44. Now we divide each side by 11. And after you do the math, you get x equals 4. Same philosophy applies to number 61. Those are easier numbers to work with. I'll give you a hint. The common denominator will be 10 for all numbers. (62 to 65). Let's see here. So the problem is, I'll change the numbers again. I'll say x plus 2 is greater than or less than or equal to 4, rather. Less than means greater than or equal to 4, right? So first thing is, we treat it as if it's an equal problem. So we need to subtract 2 from both sides, just like normal. And when we do that, we get x is greater than or equal to 2. Now, I asked you to draw this on the number line. So here's the number line. Here's 0, 1, 0, negative 1. This is 2. And this is 2, negative 2. So let's draw another color. So x is greater than or equal to 2. Because it says equal to, right, it's going to be a filled in circle, okay? And x is anything that is greater than, x is equals anything that is greater than or equal to 2. So it goes this way. Make sense? Alright, so that will include numbers 3, 4, 5, etc. Next problem is y minus 10 for 64 or 65. I'm changing the numbers. Y minus 10 is less than, let's say 5. Well, same thing, we gotta get y by itself, so we'll add 10 to both sides. We added 10 here. We added 10 here. We subtract, and then we're left with y is less than, negative 5. There we go. So let's draw this. I'll have 0 here. I'll have 5 here, and then I'll have 10 here. I'll put a negative 5 here. Alright, because y is less than 5, it'll be an open circle, it's not equal to, and it's less than, y is anything less than 5. So then it goes this way, right? So that's how you would do that. So 66 to 67 is x over 5, so is greater than 2. So same philosophy, all you need to do is multiply both sides by 5 over 1 and then graph it. Not hard. Next is we have this and problem. So let's figure that out. So we have x is greater than 2 and x is less than or equal to 5. Alright, so let's draw the line, number graph. I'll have this as 0, 1, 2, 3, 4, 5, and 6. And I'll have negative 1 here. Alright, and onwards if you wish. Okay. Now, x is anything less than 2. Alright? Anything is x equals anything greater, x equals anything that is less than 2. So the line will go this way. Alright? And then it says, next one says x is less than or equal to 5. Alright, so that's a closed in circle. X is anything that is less than or equal to 5. And then here. Okay? And you see it intersects, you see where it intersects, which is here to there. Alright, now hopefully that makes sense. Now the next one, 71 to 74, you see this weird symbol looks like that. That is the same thing as saying and, okay? Same thing as saying and. So don't let that deter you from answering that problem. That's not difficult after I explain that. So that basically takes care of all the algebra portion. Now on the back page, 72 to 200 or 72 to 100 are word problems. So they're not difficult, but I'll go over a few of them, and the rest of them you need to apply yourself or look in the book. Alright? Alright, just to bear with you, this program that I'm using records only up to 45 minutes. So after 45 minutes, you're on your own, whatever problem is left. So let's see if I can get one done. So number 72 to 76 says, how much money must be invested at 7% a year to produce a yearly income of at least $875? How much money, alright, so it's basically is how much money, okay, so that's the unknown, must be invested at 7%, alright, at 7% a year to produce a yearly income of at least $875. So it's saying that our equal is 875. We're trying, right? And we're trying to figure out. It says how much money. That's the unknown. So we'll put that as money at 7% interest. At is another word for of, so that means at 7% interest to produce a yearly income of at least 875. So there we go. All we have to do now is find out what m is. So to find out m, we have to divide both sides by 7%. Another way to write 7% is 0.07. All right, and same here, 0.07. Divide this by 0.07. Alright, and when we do that, it's basically 7 divided by 87500. Alright, so that's 7. This is 17. This is 2. That gives us 35. 500. So you see what the answer is. I'm not going to say it, but you see how much it is. Alright, I want you to make that clear for me. I shouldn't even have done that much. Alright, next is the difference between a number and 25 is less than 82. So it's the difference, which means subtraction. So that the difference between a number and 25, so the difference between a number and 25 is less than 82. What could that number be? So we have 25. The difference between a number, so x minus 25, right? The difference between a number and 25 is less than 82. Well, this answer is going to be less